Okay, so good afternoon, everyone. Today, Antonio and I, we're gonna present you the adventure of two full stack developers on creating an MVP in blockchain with Flow, right? So we are gonna talk to you about our journey, learning the Flow, right? So my name is Sandro. I am a full stack developer. I love web development. During my career, I have played with Java, JavaScript, and a little bit of DevOps. I'm also passionate about airplanes, so maybe I'll become a pilot in the future. Let's see how things will be. Antonio, do you want to introduce yourself?
Hey guys, I'm actually a Juventus developer. I'm working at a lot of different projects on my career. I mostly with Java and Kotlin and backend, and but I love to play with JavaScript and other languages as well. And I just playing with Cadence and Flow blockchain and stuff. So Sandro, can please start explaining us? Let's get started.
Okay. All right. So as I said, it's about the journey, right? We're not expert on Flow yet. We're just planning to be. And well, so it's about our journey, right? What we have learned. We hope we can pass to you some concepts of the cadence and Flow itself. And hopefully we can answer all the questions. If we cannot answer some question, maybe we can learn from it, right? Okay, so well, where Flow is being used, right? Besides, it's a pretty new technology. It's been used for a lot of companies already, right? It has a very nice ecosystem already. So, and I can show you a little bit how Flow works. So that's just a little GIF here. So basically, the idea here is to explain that each node or each machine on the Flow network, it has its own responsibility, right? One for execution, verification, and consensus. So each machine can have this responsibility. We don't have two responsibility on single machines, right? So just to give you guys an introduction or an overview on how Flow works, right? You also can just take a look on this site here. It's a very nice one. Here you can see live all the transactions that is being executed on Flow when what blocks are being created. You can see it live. It's a very nice thing. And well, that's how Flow works. Of course, that's a big picture. Our presentation will be more focused on cadence language and how you can manipulate the resources, NFTs, and collections inside the Flow. And we're gonna, have a small application. So Antonio will do a hands-on with you guys to show the concepts I'm going to explain here. Okay. So Cadence language, right? It is a pretty new language. It was created by the Flow team, so it runs over the Flow platform. It's a language for a smart contract, right? And it has a strong type, just like we have in Java. On this presentation, we're going to do some parallel with Java just to get it better to understand the concepts. And also, it is capability based. So we have some ways to handle security in Cadence. That's a pretty, yeah, I think it's a pretty nice way. So that's just an introduction of the main features of Cadence. And we're going to see all of this on this talk later. Okay. So I said that Cadence language is a language for smart contract, right? So I think you know already what is smart contract, but just to give you a very small overview again, maybe, a smart contract is a piece of software that runs in the blockchain, right? So here is the syntax of a contract in Cadence. So you can see that's pretty much like a class in Java, right? We have a contract that could be a class, and we have the attributes here, that could be, we also have this init that could be the constructor and functions, right? So just basically like a class. And we can compare it with a singleton service. I don't know if everyone here already worked with Java and Spring Boot applications, but you have a services, and this service can be accessed from everyone on the application. So it's pretty much like a singleton service in Java, okay? And well, every application we do, for example, if we develop an application in Node.js or in Java, we have to deploy it in some providers like Heroku, and then someone can access it through an REST API, right? And how can we do it for the smart contract, right? So how can we deploy this contract, and then how can we execute these functions? Well, in the flow, we have the concept of deploy the smart contract in an account, inside an account, right? So maybe I can show it in a better way on the playground. Sorry, just put here. Okay, so we have some ways to deploy contracts in Cadence. We have the emulator. We can run emulator locally on our machine. We can deploy the contract in a test network that Flow provides to us. But for to get things simple, we resolved to do this presentation on the playground, so it makes things easier to understand and execute. Okay. So I just said that contracts needs to be deployed in accounts, right? So here I have some accounts examples, right? And then, for example, I can deploy this contract, this hello world contract. Sorry, this hello world contract on this 01. Okay, so just like pretty much the same thing I shown on the presentation. I have hello world here, the attribute and the method, right? So I have a magic button here. When I click, it is deployed, right? Of course, in a real world, we have command line to do that, but just to get things simple, I can use the magic button. Right, so this contract is already deployed on this account here. Great, so how can I execute my hello method, right? Well, we have two ways to execute things on the contract, right? We can execute things through a script, or we can use transactions, okay? So a script we always use to read the information from the blockchain, from the smart contract in the blockchain, right? So we don't need to authenticate to read information, okay? Of course, it depends of you have to configure on your contract the access of the information. I will not talk about that right now, but we don't need an authentication to read. So what you can do is you can just create this script here. Let me copy and paste to save time. And you can, here on the playground, you can add a new script. So let me add a new script here. We can paste. Sorry. In presentations, we get nervous, so things. Okay, that's two. All right, so import. And here I have to import the contract I want to execute something. That's pretty much in Java. In TypeScript, we have this as well, right? So I have this reload word from an address, right? This is the address of the account I had deployed the contract to, okay? 0x01, okay? And then I have just a main function here, and I can call hello world, right? The name of the class dot hello, right? So hello world, the name of the contract and the function, okay? So I can rely on the magic button again, and there we go. I have a hello world here, okay? So that's a hello world using a script. I can also do a hello world using a transaction. Okay, so you're gonna see that the structure of the transaction is a little bit different. Right, so let me just create the transaction here. Okay, so here I imported again from the account, right? But here I have this prepare, and you see that I have an alt account here. So every time I execute a transaction, I need to authenticate. And I will not go into details on how authentication works behind the scene. Maybe we need another talk for that. But for now, just keep in mind that I need to authenticate. And the playground provides a very straightforward way to authenticate the transactions, right? So I can just inform which user I want to use to authenticate, right? And when I have a transaction, I don't need to care about the instantiating this alpha account. Cadence will inject it for me automatically whenever I have a transaction, okay? And I can also use two authentications, so I can run a transaction that two people must to authorize to authenticate, right? So you can see that when I put a second parameter here, it will ask me a second signer. Okay, so I can select a second signer here, and I can execute. Okay, so hello world. There we go. All right. So I just would like to give you an introduction of what the smart contract is in the Cadence world, in the Flow world, how we can access these scripts and transactions, right? That's just for you guys to know the structure, but Antonio will explore more these concepts on the hands-on. Okay. So now, just to add more words, small words here about the cadence. It also has some primitive variable types, right? Which you can. I have a link here where you can see more information about this. It uses let and var for constant and variables. JavaScript developers is a bit upset about this because we use here let for constant, and let is not for constant JavaScript. But yes, this is how things works here on the Cadence. So we have let for constant and var for things that can be changed. Okay. And when I create functions in Cadence, I can pass a label. So it's pretty good for readability, right? So where, for example, here I declare the function, and now I'm just calling this function, right? So I can just put a label here to make it easy to read, to understand what is the name of this attribute. So I can declare it on when I'm using the function, not only when I declare it. And if I don't want to have an alias, right, a label, I can just put underscore, and when I call the function, I don't need to pass the alias. I just pass the name of the program itself. Okay, so regarding the composite types, we have two main composite types. We have struct and resources. I don't have much thing to talk about the struct because it's pretty much like a class in Java, right? So I have the struct here, the attributes, and the init method is the constructor, right? And I can just instantiate an object, let's say, of this. And then we use when we want to put data together, right? Pretty much like a class in Java. And the resources is also pretty much like a class because I also have the init, which is a constructor. I can have also the attribute. But the difference is that when I create a resource, it's a special thing. Resources can only exist in one place at a time, right? I cannot, for example, create a resource, put it in an array, and then put the same resource in another array, and the same resource in another array. I mean, creating not instance, but replicate these in variables on Cadence. I need to use it exactly once at a time, right? So to get it more simple, for example, when I create a dog, right? I have to use this special word here. When I create a dog, this is a resource, right? Dog is a resource. When I create a dog, I cannot use this equals, right? Because the idea we want to express here is that I create a dog and I move this dog to this variable, right? So we don't use equals. We use this special move operator here, right? So it means that I created the dog and I moved the dog to this variable. Okay. And so when I create a resource, I need to do something with that, right? Because it's just like I mean, we use a resource to handle NFTs, right? For example, here that's why we cannot create replicas of a resource because the resources are meant to be unique, right? So that's how NFT works. So when you are working with NFTs inside Cadence, the language gives you the support to don't make mistakes, So because you don't want to lose your resource, or you don't want to duplicate your NFT, right? So that's why we have this rule for resources, right? And so when I create a resource, I need to do something with that, right? So if I don't do anything with a resource, I'm gonna have a compilation problem. I'll not be able to deploy my contract because it will identify that I have a loss of resource here. I create a resource, but I'm not doing anything with that, right? So one thing you can do to solve your compilation problem is to destroy the dog, but it doesn't make sense, right? Because you create to destroy, but sometimes it's important to have this destroy here when you're not using your resource anymore. But Antonio will explore more about how can you use your resources. Okay, so we have some small rules here, like if resources can only be created inside a contract, right? And that's it. So sorry, I think I talked too much, but I just would like to tell you and let you know the main concepts we have in Flow and Cadence. Now Antonio will do a hands-on with us. So we are gonna have this application. It's a smart contract application, small one. So I can create NFTs, right? I can create dogs, and I can donate dogs, right, to other people. So Robert can donate dogs to Anna and vice versa, right? Anna can see the dogs of Robert, Robert can see the dogs of Anna, but the only thing here is that only Robert can donate his dogs, right? So Anna cannot donate a dog that does not belong to her. Right, so it's a very small one, but I hope it to be a nice smart contract application to clarify all these theoretical things I just explained. Antonio, could you
Sure.
please?
Sure. So let me share my screen and okay. Okay, I guess you can already see my screen, right?
Yes, I can.
So we have here, I'm using the Flow playground again because we just have to be more practical, more pragmatic, because if we try to do this by typing, we will lose our time. We waste our time of our presentation here. So we have some things already made, and we just explain to you, and we play around with the code, and let's see how it works, right? So we have here a contract, a docs contract that we hold our docs, right? And we have this little variable here that will like a counter for total dogs you have in the world, right? Let's say total dogs you have in the regarding the dogs contract. And when we declare a variable here, we need to initialize it every time. So we start deploying the contract, and we deploy the contract over here. The total dogs is 0. We don't have any dog at all. And you're using some structure to save some information about the dog, right? Because we don't need to have a lot of variables here with name and age. So let's use a structure that's a composite type, and then we saving the name, saving the age, and then we're using some type from flow, like segment int 8, because age, well, the dog does not live too much, does not live too long to pass this maximum of this type. And we also have breed, that's almost every dog has a breed, and the height, weight of the dog, right? And we also need to initialize the dog info, the structure, and we have this init method. That's a similar thing we have in Java. If you work with it, we have closures and have to provide constructors. And when we need to initialize all the parameters in the constructor, is something like that, right? So this looks like a class. We can create, instantiate, copy, and do everything we can. We already know with this. But then we have a resource. So this resource is everything that I'm talking about. We can't copy it. We don't have, must have it only on one place. And we are assigning for every dog an ID, because when a dog is created, we have ID1, and the next dog we have ID2. That's the idea. And we use the total dogs variable above to like act as a counter. And every time we create a dog, we create a resource here, we increment the counter and assign this next the counter to the ID, right? And then the user need to construct the dog by passing this structure of the dog inf of the information we just said about, right? And then we have the resource of the dog. And the curious thing is that to create a dog, you can't create outside this contract. You should not, you're not able to create a resource outside the context is declared in. So you need a method, like it's public method over here. And to create a resource like minting, I think I already sound in the previous presentation. So you need to mint a dog. It's like act like a NFT. So mint a dog and pass the dog info for it. And then we just use the create operator here to instantiate, let's say that a dog with a dog info, right? And then this instantiation is moved to the return result. And this is at here to say that, well, this is not a reference, it's the actual dog. We're moving the dog over here, right? So we have the dog, we have the create method, we have the structure to hold all the information. And well, let's try it, right? Let's try to mint a dog. So I have prepared here a little mint script here. So you can test mint a dog. Before we have to deploy the contract, I just forgot it. So the contract is deployed on the account 1 here. Let's say it's Robert. What's Robert's account? And let's meet. So means just reference the contract on the account number 1, and then we need to sign the transaction. So we choose to sign with the owner of the contract. We create here. So I creating a dog here, a dog information with let's say the name of the dog is Bilou. You want it to be called Bilou. Don't ask me why. And then you have 3 years old. He's a poodle, and here's his weight. And after we prepare the structure, we can call the method to mint the dog, right? And pass the dog information. And then I can use the equals here because it throws an error for us. You could not copy the resource over here. And it will, after that, the resources will be in this dog variable, right? And just for the sake of the testing, we are logging out on the console the dog and destroying after all, because we should provide a destination for the dog. This time we will kill the dog, right? Should not blame me. So let's try it. Let me click try again. Okay, here's the logging on the console, so you can see information about the dog that's just minted. What's minted and below here are dead because we just destroyed it, and it's not very useful to do that, right? So the one idea that we have on Flow is that we can save the dog on the account, and I have prepared here a little replacement for that code, and we can do something like that, right? So you can save on the account that's signed in, like the account number 1. You can save the dog. Dog is moved to the storage. Let's pay attention to that. That's number symbol over here, and the storage is like this path. We use the storage with the storage path that is actually a literal here for a type, right? And only the owner can access this storage domain. And well, let's try it. If I save that, ready, so transaction finished. So I can go to the account number 1 and see the storage here. So they have the dog below. Dog below is on the storage, is leaving, is not killing it anymore. And we also can use this script. Remember, script does not need to be signed in. You just can execute in the blockchain. And we can provide this list. We just try to list the dog. But well, let's try about it later. Let's keep on the mint here, right? So I can save a dog below, and I can save another dog over here. Let's say I will save a dog called Dexter. Right, I can just run the transaction again, and then I can have 2 dogs on the storage, right? Well, but it's not very useful to have keeping dogs on different paths on storage, because usually, Robert, you have a lot of dogs, right? And then we can just keep a dog on each storage path here. So Sandro, I ask you how we can hold a lot of dogs here and put on account a lot of dogs to the account. So
Okay.
that's up to you now.
Yeah, so we need to use a collection, right? So hope you can get yeah, I think you guys can see my screen. So, well, great. Antonio has created some resources from dogs, right? But he saved the dogs on the storage. But what is that storage, right? We didn't talk about that yet. But before we talk about the storage, let's talk a little bit about collections, right? So as Antonio shown, we have just created a resource and saved this. But it would be nice to have a collection where I could put all my dogs inside, right? So it would be easy to scale, to maintain, and to control. So we could create another resource, right? And the resource is called collection. Here it could save all dogs I have. And then I could have some methods here, right? So deposit, for example, someone could give me a dog, could deposit a dog to me. Or withdraw, I could remove the dog from my collection and give it and donate it to someone. And someone can list my dogs, right? I have just a list of dogs. Maybe someone wants to see the dogs I have. So they can just use this list dogs here. But there's an important thing, right? How can we secure this, right? Because only the owner of the collection should be able to withdraw, Other people, because I have some dogs, and then some people came and take the dog from me, it does not make sense, right? Only myself can get this dog from my collection and give to someone. So we need to set up some security permissions here, and now we are going to talk about capabilities of Cadence, okay, and security. So, but before we talk about that, it's very important to understand about interfaces in Cadence. Okay, so interfaces works again pretty much like in Java, right? So, for example, let's just show you a little example here in Java code that's not Cadence. Okay, so let's say I have a person, and here I have name and credit card. Okay, and I have some getters, some to get the name and get the credit card. But it doesn't make sense to let this method available for everyone, right, to get the credit card, because it's a sensitive information. So what I could do, I could just create an interface, right? And I can make my person to implement my interface, right? Then I can use polymorphism here. So for example, every method that receives the person itself, the object itself, will be able to do the get credit card operation, right? But if I receive the interface, right, I'll not be able to get this credit card, only the get name, because the get credit card is not available on the interface. But when I create that, I create the person, right? I create the person only once, and I can use exactly the same object for both methods. It's exactly the same object. The difference is the access. Here I have access to credit card, and here I don't have. Here I don't have. Here I don't have, okay? So that's how interfaces works on Java, and it's how interfaces works in Cadence. Of course, the syntax is a little bit different, right? So here I have my collection. It implements an interface, right? And here I have deposit, withdraw, and list dogs. But only the owner has the access to the collection, right? So the owner can access the withdraw. But other people that is not the owner should not have access to withdraw. So other people should only see this object with this interface behind. Okay, so they could just list and deposit dogs, but they could not do the withdrawal. Okay, I just did this collection public here to make the example simple. Normally the Flow team, they recommend to have an interface for each operation like this, right? But just to keep things simple, let's just call it collection public, okay? And well, now we're gonna talk about storage that Antonio shown you, right? So storage, it's as the name itself says, it's a place where you put your collections, your resources, and it lives inside the user account, okay? And so I create, for example, here, I can create a collection, right? Because it's a resource, just like I shown here, it's a resource. So I use the move operator to put it on this constant variable. And I save this collection on /storage/dogs collection. This /storage is a path that only the owner can access, okay? Only the owner can access. And then I created a resource and I put it there. So you ask me, okay, but what about the public access? What if you're just telling me that only the owner can access this /storage? What if other people, the public people wants to access this object? Well, we have another path, right, on the user account. We have storage, and we have another path called /public. Right, on this public, I put everything I want that other people, other people to have access. And because it is /public, everyone on the network can access this, everyone. We have a third path, that's the private, right? The private is a path that only can access the people that I allow, the people I give access. It works pretty much like the same, the share, when you are sharing a slide on the Google Slides, for example, right? You can copy the link and share to all, or you can inform what is the email address of the people you want to have access to this. But on this presentation, we will not include this private, just storage and public, okay? So two things to have in mind here. Storage, only the owner have access. Public, everyone has access. But you don't want to put in the public an object that everyone can access. For example, a method that everyone can access. For example, the withdraw, right? You don't want to put an object in the public that has this withdraw method. So what we do, we use interfaces, right? We use interfaces. So here I create a resource, I save this on the storage, and now I can create a link, right? This link, it works pretty much the same, the symbolic link we have in Linux. I don't know if everyone is familiar with Linux here, but it's worked pretty much the same. So I create a link and I say, okay, I will create a link. I want that the return of this link is a collection public, right? So collection public is this guy here. So list dogs and deposit dogs, right? And I want to save this on public dogs collection public, right? On public. And what I want to save this there, I want to save the object I storage. I place it on the storage, right? So here I save on the storage, and here I get this object, and I create a link to this object from this object to this public dogs collection public, right? Then everyone that access this address here will get an instance of the object, of the resource, right? But not the complete, they will not have access to the complete functions, only the functions that I described on the interfaces. It's a little bit hard to explain this. I hope it was clear, okay? But it's basically that. And then how can I get, right, this object here? Well, I can use a script, right? So I can use a script that expect an address. And then I can just say get account, right? So this get account here, you don't need to worry about this. This is a global method in Cadence. It's just like window, if you are familiar with JavaScript in the web. So this get account is a method that is globally on the Cadence. You can just call it from your script, and you pass the address here, right? So then you do this get capability. It's just like I'm getting the public information, right? So I'm getting something. What I'm getting an object that has this collection public. From where? From public dogs collection public, right? So if you see, this here is the same path that I saved, right? I created the link. I created the link here, and now iScript is trying to get this information. And then I call this .borrow. Borrow is just borrowing, right? Just a method on Cadence that means that I am, getting this information. And I have a panic. Panic is just like throw in Java. It's just like an exception. And so if I have some problems borrowing this information, just do a panic and put the reason of the error here. And then at this point here, this dogs collection public is my resource with an interface behind, So I can just do a list dog. So I will see all the dogs that the user has, but I can just see it. I cannot withdraw. I cannot do anything else. That's capability security based. When we put this on the Cadence slides, you're gonna hear Cadence is a capability security base. That's what it means. You can save resources with an interface behind, so that people is allowed to get only the things that is in the interface and not your entire object. Okay, so again, I'm talking too much, but just to give you an introductions, thank you, about all of this. And now Antonio is going to finish your application, donate, and list. He's going to show this live for you.
So let's continue. Yeah, Marcel, the script is versatile. Everyone can use the script and run it on the blockchain, right? So let's see. So I completed here our contract, and I included the resource Sandro was talking. So we have our resource collection, and our collection already is like implementing the collection public, like you can see in your language, like Java, like Sandro showed to us. So any user would be able to reach this collection public as soon as you create the link, right, for this interface.
I think you're not sharing your screen, Tony. Sorry.
Oh, I'm sorry, I forgot to share my screen. Okay. Okay, are you seeing now? Okay, now I'm seeing. Okay, are you seeing, Sandro?
Yes.
Okay, sorry guys. So I will start from the beginning. So here now I included this resource collection. on the same contract we have talking about the dogs here. So I talked about the struct, we talked about the resource, talked about the mint dog, and then now we have the interface for the collection public and the collection, right? Collection resource actually, and its collection resource is implemented in the collection public, and we can see that those who can access this collection public can call these two methods over here, can deposit some dog and can list dogs on the collection, right? So as the same thing we saw in the dog, we have to initialize our variables. It's actually not a variable, it's a constant with all the dogs in the collection. I have a method here to deposit dogs. So it's moving the dog that those are sending to the dictionary. We have our method to withdraw. It's like withdraw money, but it's not money. Actually, it's the tokens, the NFT. We pass the ID. The same ID we are using here to implement the dog, this ID over here. That's the reason it's pretty important to have. And then we can pass that ID over here, and it will be removed from the dictionary, so that we're not keeping that dog in the dictionary is being removed and move it to this constant, and then move it to the constant to the color actually. And you can see that on the return type you have this at saying to you that the actual dog is not anymore on this dictionary. It's moved to the result type of the method here. And another method over here is the list dogs, and then we provide a dictionary, but this time is not dog, it's dog info. It's just a way that you can list the dogs on your collection, and the dogs are not resources, are structures. So you're just providing the information about the dogs. This is some information here, and not their NFT itself, not the resource itself. So this has just the dog information. And as you already said, also on the dogs, and we have to destroy any resource we create on the resource. So if the resource of the dog, I think I didn't show it here, but okay. Every resource, when you declare a resource type on the resource, you need to provide a destroy method. Sometimes Cadence needs to call destroy the transaction and needs to destroy any resource that's on it, right? And at the same time, same way that dogs need to be minted and have a method to be minted, collection also needs to have a create collection method because it's a resource. Resources that same way can be created outside. And that's it. And the last thing here about this is included here, this collection, these three methods here to create a collection, put here in this constant, and I'm saving the collection in the account of the user. This account is the same account that's have the contract deployed in, right? So if I'm deploying the contract to this account, it will run this init method. So I just run it. It's running this init method on this account, and this is creating this collection, is saving on the storage of this account, the dogs collection, and also creating the link to the collection. So the collection is stored, as Sandro already said, the collection is stored in storage, so in the owner can access, and then providing the link to the storage on the public domain here, right? So the name of the link is dogs collection public. This dogs collection public on the public domain is pointing to the storage, right? And you just have the access to the collection through the collection public interface. So you only have access for those who gets this reference here. Only you have access to the list dogs and deposit methods. You can't do anything else, right? So that's pretty much it. So we have now a collection, and we can put dogs in the collection, right? We can mint dogs and put it in the collection. Collection already exists because we already deployed it on account 1. And I already created here, so I did update it here. So let's update this script to mint the dog, because before we were minting to the storage and put in a specific path over here. But this time I will put the dog on a different place. I put the dog on the collection. Right, so it's pretty different. It's a transaction pretty different. We have to get the reference to the collection, and then you have to mint the dog and deposit it, right? So if I mint this dog now and run this script, So that is it. The dog is minted, and the collection is so now the account one has the dogs collection. You can see here, and the dogs collection have the dog is just minted up. The dog is, let's say, which dog is it? Is the Podo? Is the blue dog, right over here? And we can list the dogs. So we have a script. Anyone on the network can run this and get the contact public here to access the collection on the account, right? So this script, I just need a parameter that's the account we are trying to list something. We're trying to access on this account, this capability, this interface here on the, let me see if I can move here a little bit to the right. Well, I can put this way. So I can access the dogs collection public on the public domain and then borrowing like Sandro already showed you. And if it is not able to do that, it should panic. And after getting this interface reference to the collection, we can call the list dogs method, right? So let's test it. I would try to list here on the account one. If you do this, let me clear the console to see it better, right? So that's it. We can see now the collection of the account number one below here is being returned. Anyone could call it and return the same, right? And now the next thing I want to show is to transfer the dogs, to like donate dog for someone, right? So let's say this Robert is breeding dogs, raising dogs on his home, and he wants to donate dogs. So someone here wants to have dog, wants to donate a dog that he's raising, right? So if you go back a little bit to the slides here, you can see that, let's say Anna is going to pick this dog for her, right? So the dog must live somewhere. So the dog must live in this collection. Actually, you can't live like in any other place. You need the collection to live. And actually, Anna is a new account. It does not have a collection yet, right? We can't even list dogs because we tried to get a collection public on the Anna. Anna does not have a collection on the dogs. You can't hold dogs yet. And you have to create a collection for Anna, right? Like a place where Anna can put her dogs. And you have a little transaction already made here that does almost the same thing that's done here. When you deploy the contract on the init method, yes, I said to you that the collection is being created and is stored on the storage of the account of the accounts that's deploying the contract. With this time, I don't need to deploy the contract. The contract will live here on the account one, will not live anywhere else. So on the account two, you will just need a collection to hold the dogs, right? So here, so you have a transaction, you created the collection and save it on the account of the caller, take attention to that, and create a link the same way we did for the account one. So this time I will not run this for the account one. I'll run this for Diana. Let's say this little girl is Anna, and we can just send this transaction for her, right? Ready. So Anna now has a collection. I can try to list things on Anna. Let's try to list something. Anna's address is 2. Because I could that one. So Anna has an empty collection over here. And just for the sake of to be clear, if I try to list for account 3, account 3 does not have the collection and it found 0, right? So it just worked because we created the collection for Anna. And if you try to create the collection for the account 1, I try to list, we already show you the dog is still there. Bill is still on account 1. So the idea is to bring the dog from account 1 to account 2 to donate the dog for Anna. And I have another transaction over here that does that, right? So that the transaction just pick the collection for the account 1 and pick the collection public for the account 2, right? And then the collection public also has a deposit method, so you can save on it on that account, on that collection. And then you just withdraw from the account 1, if I can show it here, and deposit your account 2, right? That's what script does. Does not anything more. It's not very complicated when you get it. And then you need to provide a target, right? And where does dog comes from? So dogs will come from account 1. That's the account that's signed transaction. It needs to be signed because we are withdrawing, we getting for the collection on the owner is allowed to access the storage to get that. And then you get from the account 1 and bring to account 2. So the target of the dog is account 2. And let's say the dog ID. So the first dog we minted, every dog starts with account 1 and 2 and 3 on the network and goes to the limit of the integer, let's say that. And then we can just pay, the first dog is the number 1, you go to account 2, and let's just run it. If it worked, nice. And then we can just test it now, right? So if I go back to the list dogs, and if it try to list for account 1, guess what? It should not be there anymore because the god dog moved to account 2. So account 1 should be empty. That's it, right? If I try to list account 2, delete it and run it again. So account 2 now has the dog, and the below is there. So below is found, right? And that's it. Like, this is pretty simple example, just show you the core concept and how you can make things work here. Like, we can move actually other things besides dogs. You can move more interesting things if you want to. But that's pretty much the core concepts of the cadence and flows. But there is much more to show you. I'll head over to Sandro. Now, Sandro, you can continue with the next thing to show there.
Okay, well, we almost finished it already. So the only thing I would like to present now is just to give some words about tokens that's fungible tokens, right? About vaults, because when you talk about NFTs, it's something that is very expensive, right? Everyone is selling and buying NFTs, and here we just gave an example that we are donating dogs. We just not included the pricing and fungible tokens on this example because it would become a little bit complex to explain, and maybe it wouldn't be helpful. But I just would like to give you guys here how we transfer fungible tokens. How can we transfer money, for example, instead of dogs? So because the concept is a little bit different than other technologies, right? So, for example, if Robert wants to transfer, $10 maybe for Anna. So it is not just an operation that I pass 10 to Anna. I need to do some stuff behind, right? So I need to use a vault. A vault is also a resource, right? Just like we did for collection and for dogs, vault is a resource, but it has some specific rules. So for example, if I want to transfer $10 to Anna, first I need to create a temporary vault, right? So all vaults has a balance. All the vault has a balance. So I have this vault here, it has a balance. So if I want to transfer 10, I withdraw 10 from this Robert vault, and I put this 10 in a temp vault, right? So I don't transfer 10 for Anna. I just create a temp vault, another resource, a temporary resource with them. And then I pass this resource to Anna, calling this deposit method on Anna's vault. And then here, Anna will get the balance of the temporary vault and will sum with her balance, right? So it will, just get the values from here, the balance from here, and include on her vault, and she will destroy this temporary vault, right? So that is how things will work. Maybe we would need another talk to include more examples with vault and maybe to explain it in a more clear way. But just keep in mind that when transferring fungible tokens in Cadence and Flow, we don't transfer numbers. We just create a sub-resource, not a sub-resource, a temporary resource of the main resource, and we transfer this temporary resource. This is merged with the vault of the other people. The balance is merged, and then the temporary resource is destroyed. That's pretty much how it works. Okay. And well, to finish here, we have some tool sets, right? So for example, as I mentioned before, I think we have the test net. We are just using the playground, but we have a test net, which is a blockchain environment that is not official. You can use this for testing. We have also the main main network, right? That's in the, to deploy a contract on the main network, it needs to pass to a evaluation process of the flow team, and you need to have tests on that. But for you to play, you can just use this test net, or you can use the emulator. You can just run the emulator on your own machine, and you can just play with that. You can deploy your contracts. You can use this FCL. This is just a JavaScript SDK, right? So all these scripts and transactions that Antonio runs on the playground, we can use the SDK to do that. I wish we could have time to create a UI for this application we did, right? So we could have a UI to list all the dogs. We could have a button to donate, and you could create an application with React or NuStack or your favorite framework, and you can use just JavaScript SDK to send this transaction to blockchain. Like, for example, you use Actions to execute REST API calls, you could use FCL to execute blockchain transactions and scripts on the flow. And of course, you have this CLI. You can also use the CLI to run the scripts as well.
I wanted to show some CLI, but I was pretty out of time here. But
yes,
there's a pretty much good things to show. We have VS Code extension. You can run the emulator there. You can just program on VS Code. Don't need to program a playground, and you can test your application emulator. And there is also a client library for JavaScript that you're seeing here. There's a testing library also if you want to make any test there. There's a lot of things that we don't have time to cover everything. But I think that's it. If you hope you like it.
Yeah, it's a very hard subject to explain. I hope we could at least make you guys understand some percentages. You can always approach us if you have other questions. As I said, we can learn from the questions as well. And talking about questions, do you have some questions? Do you have some questions? If there's a silence, it's because everyone understood everything. No one's understand anything. I hope it's the first option. Yes, thank you very much, Mortaro, to answer the questions on the chat. Thank you very much, man. And
yeah, thank you. A lot of questions over here.
Yes. No questions? Well, if there's no more questions, I just would like to tell you, I don't know if all the audience here is all working on the A Studio, but if there's someone that's not working for AE, we have some open positions. We have very interesting projects, very exciting projects. Unfortunately, we cannot share with you here because it's client projects, but I assure you that it's very nice projects to work. If you're a blockchain developer, you are very welcome. But maybe if you're not a blockchain developer, but you can learn things fast, you are also welcome. You can apply, right? There are many reasons to apply to our process, right? We are very nice people, and you're gonna have a lot of opportunities to grow, to speak and to maybe fix some syndrome, some imposter syndrome you might have. Yeah, that's it. So you are welcome to apply to our process if you want. I'm sure you're going to be very happy working with us.